So let's go to solve this question. This question is say about an electron that is in the presence of an electrical field. This is the electron. The electron is moving with a big velocity to the right, and the force is going to the left, but the force, what it's doing is decelerating the object. The object will arrive to the final plate with a velocity that is lower than the initial velocity because the force is going to the left. It's creating an acceleration to the left. So for sure, from this any other solution, the solution should be a velocity that is lower than the initial velocity. No way, so maybe we can answer the questions. What is the initial velocity? 2 by 10 a la 7 is the initial velocity. So this cannot be, should be something smaller. Yeah, something smaller can be something smaller than 2 by 10 a la 7 could be 1.5, 1.2 is 2. So this one cannot be. So there are two only possible questions, possible answers. So this is a correct question. So how do I solve it? How do I solve it is in the following way. So let me.
Professor, for this question, would it be okay, like if we did it like more simpler, just solving for the acceleration by comparing the two forces, like QE equals MA, and you get the formula for acceleration, and then just plug that into the kinematic formation,
Yes.
kinematic equation of movement. That way we get the final velocity. You know, because I think sometimes it gets a little confusing.
Yes, you can do it like this. You will have the same result. You can do it like this. Let's go to do it also like this. Let me finish how I did it and we'll do it in your way, okay? To check that the object is making, to check that we will obtain the same answer. So the force, the work, but this method is a method that you have to understand what is the idea, the philosophy of this method is to avoid to start talking about forces and to start talking about the work and the energy. All this method about potential. The intention in physics is that we need to get rid of the force, of the vector force, and substitute the vector force for something equivalent that will give us same results, because sometimes you don't know where is the force, how it's acting. So this is the method of introducing energy concepts in the problem. So the problem is like this. I have the work is done by the force is the electrical field. The electrical field is, the force is Q sub E by E is scalar ddr. So the Q is the charge of the electron, that is a negative charge. So the force is in the opposite direction of the electrical field. So if I do this dot product, it will be QE is 0, I, because the electrical field is going to the right, and the displacement DDR, it will be ddx by I. If I make the integral, that it will be very helpful for you to do it, because it's related also with the potential and with the potential energy, is Q sub E by E0 by the integral from one point to the other point. So you go from x1 equals 0 to x2 equal d, the distance between the plates. So what happened here, it would be q0 by E by x2 minus x1. By x2 minus x1 is the distance d that separates the two plates. And q0 is negative, so the work is negative. So because q0 is negative, the work is negative, so we calculate the work. So we calculate the work and we apply our equation that the work is the variation of the kinetic energy. What a force is doing on an object is creating work, and what the work is doing, changing the kinetic energy. So this is in this way we avoid to talk about the force, and we talk about the work done by the force, and we talk about what is doing the force? Is changing the kinetic energy. So we find the work, and this is the work Q by E by 2. So if we will find the work will be this amount of work. This will be the amount of work. So the change in kinetic energy is the work. The work is the change in kinetic energy. It will be the kinetic energy final minus the kinetic energy initial. Kinetic energy. So the final, if you solve it for the kinetic energy final, will be the kinetic energy initial plus the work. But in this case, the work is negative. So the kinetic energy final will be lower than the kinetic energy initial because the work is negative. So we'll plug in my equation, 1/2 mv/s squared equal 1/2 mv0 squared plus the work, but the work is negative. So if I work with this problem and put the numbers, I will obtain the solution, and this solution will be this solution, this is the solution, 1.5 by 10 to the 7, and the problem is solved, and the answer is correct in this problem. So I'm sorry, the answer is correct. You're wrong, but you're right in the other two questions.